Right, so I'm not going to go through all this, but we'll look at different aspects, different structural aspects of central nervous system. We'll then talk about higher brain functions, the different wave patterns present in your brain, and also talk a little bit about sleep and wake cycle, and the clinical imbalances that we can see with central nervous system. Okay. Right, let's start with cerebral white matter. So we have covered the basics in the last class, so you must be able to tell me. Cerebral white matter, this is very important because it's responsible for communication between the different cerebral areas, and also it helps in communication with the lower central nervous system as well. So when we say white matter, we know very well that it's got lots of what fibers? Myelinated fibers, as it's given here, that's good. And the basic pattern remains still intact. All right, so this is cerebral hemisphere. So you can really see there are two hemispheres, one on each side. And if you look at this picture, it clearly looks very identical, isn't it? But the functions of the left hemisphere and the right hemisphere are more or less, I would say, totally different. Because your left hemisphere, what does it control? What does it do? For most of them, it's the dominant one. And what does it mainly control? Your language, your logical reasoning skills, all that is controlled by your left hemisphere. Whereas your right is more involved with creativity. Okay? And here in this picture, which looks much crowded, but if you just try and differentiate the colors of the fibers running there, you could see three colors. The green, which is the commissural fibers, then the red, the association fibers, and the projection fibers, which are blue. Okay? So these are the three different types of fibers present in your cerebral hemisphere. So what they basically do is, they try and link different areas of the cerebral hemispheres and to the other bigger structure of the brain. So first, if you take the association fibers, so these association fibers basically unite different parts of the same cerebral hemispheres. Okay, so it's the red one, so you can see it's connecting within the hemisphere, uniting the different parts within the hemisphere. Then we have the commissural fibers, which is actually running between the two hemispheres and connecting them together. Okay. Then we have the projection fibers, which has a little bit more complex function. So this projection fibers actually connects to lower areas as well. Okay. So this is sort of a communication between the other areas of the brain. Okay. Right. Then we move on to read about a structure called basal nuclei, which is actually present in your cerebral hemisphere. So this basal nuclei is not completely within cerebral hemisphere. It covers a little bit of other areas like thalamus, brainstem, and cerebrum as well. Okay, the cerebral hemispheres. So what's basal nuclei? So basal nuclei basically consist of multiple nuclei that has its origin in different regions of the brain. And what they do is, they sort of control lots of different brain functions or the overall bodily control. Okay, so there are different nucleus. As you can see here, we see caudate nucleus and then putamen nucleus, but in this view, there is one of the nucleus which is hidden. So if you take the putamen nucleus in a different view, and if you see that, you'll be able to see globus pallidus nucleus as well. So that's actually here in this picture. Okay, so that's just medial to the putamen nucleus. So if you see the big pink one, there is the putamen nucleus, and the one smaller inside that is the globus pallidus nucleus. Because it is medial to the actual putamen nucleus, it's not able to be seen in the lateral view. Okay, but understand that there is many nuclei, and we are only talking about the important ones here. So this picture actually shows you again. So this blue one, the dark blue, is the putamen nucleus, sorry, globus pallidus nucleus. Okay, so we won't look at the function of that yet, but just understand they control various functions of the body. So the functions, mostly it's thought to influence the muscle movements. Okay, coordinating the different muscle movements plays an important role in emotion and cognition as well. And very importantly, it regulates slow or stereotyped movements. Okay? That means when I say it's regulating slow and stereotyped movements, it also has capacity to filter out disturbances or unnecessary movements. Okay? All right. So this is a mid-sagittarian section of your brain. So what I want you to really look here is the three paired gray matter structures present, mainly the thalamus that's highlighted in red, epithalamus, and hypothalamus. Okay. Right. So when you talk about thalamus, the main important thing to understand is thalamus is a bilateral egg structure. Okay, like it's a structure where it looks like two eggs are fused together. So these two bones are fused together by interthalamic adhesions. Okay, so you can see there's lots of different nuclei present there. There's anterior nuclei. It forms the superior lateral wall of the third ventricle. So there's several nuclei, as you said. The main function is to act as a relay station, more or less, like if you imagine someone sitting on a ticket counter, where they get different changes from you. You should just pass the information to you, basically, the timings and everything. And then what they do is they sort out those information, sort out those tickets, the money, everything at the end, and put them to tally. So it basically, it's the same function. It sorts, edits, and relays the information down tracked. Okay. Hypothalamus. This is basically located just below the thalamus, and it forms a cap over the brainstem, and it actually forms the inferior lateral wall of the third ventricle. So the thalamus is forming the superior lateral wall. This one forms the inferior lateral wall. Again, the hypothalamus contains many nuclei as well, and one of the important one is the mammillary bodies. We'll see it in the next picture, so we'll leave it there. The infundibulum. So it's a stalk that actually connects the hypothalamus to the pituitary gland. Okay, this is the infundibulum. Okay, so we were talking about different nuclei here again. So some of the important ones I have actually highlighted. Supraoptic nucleus, suprachiasmatic nucleus, and the mammillary bodies. So mammillary bodies mainly control your memory. It's easier to remember. Mammillary body for memory. And then we have the supraoptic nucleus. The supraoptic nucleus is very, very important because it sets our biological clock. Okay? So basically, it regulates sort of sleep and wake cycle and everything. Then we have the suprachiasmatic nucleus, which actually secretes a very important posterior pituitary hormone. Any guess what it is? Drop silence there. Alright, so it secretes a peptide hormone called ADH or vasopressin. Okay? So that's suprachiasmatic nucleus. And move on. And what does ADH do? Just a recap. Helps in water reabsorption? Yep. Yeah. Alright. So we have seen this. So overall, what we have to understand with hypothalamus is it is very important for homeostatic mechanisms. So hypothalamus and homeostasis. Okay, both starts with H, so remember it like that. There's lots of information to take in, so you've got to relate these to something or connect it to something to remember. So hypothalamus overall controls your homeostasis. So the chief homeostatic controls are, it controls various autonomic nerve functions. So ANS is controlled by hypothalamus. So what are the various functions that would cover then with hypothalamus? Mainly it would control your blood pressure, your, yes, heart rate, that's right. So the rate and the rhythm, everything is controlled by the hypothalamus. Then also your intestinal motility, so again controlled by hypothalamus, and it also controls the eye movements and all those fine movements involved. And it initiates physical responses to emotions. Okay, this is again related to limbic system, so we'll look at that a little bit later. Okay, so basically it controls your biological rhythm, sex drive, and all those functions. So physical responses to emotions. Okay. So before we go to this slide, so I said it controls your biological rhythms. So what are the disorders that we can see with biological rhythm being disturbed? Very prominent one, when your biological rhythm disturbances happens, what is that? What will happen with your sleep patterns? That's right, so insomnia. Sleep is affected. And if you lack sleep for a long time, what can happen then? You can go into a state of depression, isn't it? People who are depressive, the first symptom that they see is disturbances in their sleep pattern for a long period of time. Okay, and even just having jet lag after a long flight travel is associated with disturbances in your biological clock mechanisms. Okay, so here more functions to add. Hypothalamus, I told you, it basically controls your homeostasis. So it controls your body temperature, involved with sweating, shivering, controls your hunger and satiety as well. It regulates water balance and thirst mechanisms through the posterior pituitary hormones, regulates your sleep-wake cycle, everything. Okay, and it also does some endocrine system functions. Basically, it controls the production of posterior pituitary hormone and secretions of your anterior pituitary hormones. So anterior pituitary hormones, there's different hormones secreted from anterior pituitary. Most of your TSH, growth hormone, that's right. TSH, growth hormone, your FSH, follicle stimulating hormone, prolactin, all these are actually secretions of your anterior pituitary hormone. And posterior pituitary hormone, it only secretes two important hormones. So one we know, which is the ADH or vasopressin, and the other one is oxytocin. Okay, so that's controlled by that's your posterior pituitary hormone. That's just for your interest. So the main clinical homeostasis imbalance that we can see here is sleep disturbances, emotional disturbances, and body wasting or obesity. Okay, and also if there is disturbances with homeostasis, it can also delay the growth in children. Okay, right. We're moving on to the next structure, which is the epithalamus. So epithalamus actually forms the roof of the third ventricle. So we've been looking at thalamus, which actually forms the superior lateral wall of the third ventricle. Then we talked about hypothalamus, which actually forms the inferior wall of the third ventricle, and then epithalamus forms the roof of the third ventricle. All these are important MCQ questions. So make a note of that. All right. And epithalamus contains a very important structure called pineal gland or pineal body. Again, this pineal gland secretes melatonin hormone, which regulates your sleep and wake cycle. Okay. Right. These are just pictures to here. your brainstem includes midbrain, pons, and medulla oblongata. Okay, and you can see the infundibulum connecting the pituitary gland there. If we just go back to the previous picture, not this. I think it's the next one. Yeah. So the midbrain, this structure, again has lots of different nucleuses and different functions as well. For example, this corpora quadrigemina of tectum is a paired dorsal projection, as you can see. This is a paired dorsal projection, those two, as you can see, and this again controls many different functions. The superior colliculus, that nucleus actually controls your visual reflexes, and the inferior colliculus controls your auditory relay stations, or acts as an auditory relay station there. Okay. Right, we move on to brainstem now. The brainstem actually covers your midbrain, pons, and medulla oblongata. So we have seen this in many different places, so you've got to remember them. Okay. So mainly the brainstem, the nucleus is associated with different functions as in any other organ, but also it involves the cranial nerves. So you can see most of the cranial nerves emerging out from your brainstem area. Okay. So the nuclei present in your brainstem region controls most of the functions that the 12 cranial nerves do. Okay. Okay. So when you talk about midbrain, there are a few important structures that you need to remember. The first and the foremost is the cerebral aqueduct. What is cerebral aqueduct? So here, the cerebral peduncles. Where's that structure? So these green structures, they basically, the cerebral peduncles basically acts like pillars to support your cerebrum above. Okay, so it holds, the cerebrum is the biggest structure, it's two hemisphere, occupying around 80% of your brain mass. So these two peduncles, called cerebral peduncles, actually tries to hold cerebrum in place like that. Okay, so we have talked about cerebral aqueduct. So cerebral aqueduct is nothing but a channel that actually connects your third ventricle to fourth ventricle. Fantastic. Right. And then we have periaqueductal gray matter, which is not seen here in this picture. I think you can see it in the previous slide. One second. Okay. So the periaqueductal gray matter, that's an important structure that is involved with pain suppression. Okay. So basically initiates your pain suppression and also your fight or flight responses. So more or less like sympathetic activation. Okay. Yep, we've seen that. Right. Okay. So we move on to talk about substantia nigra, which is again a structure which is very closely linked to your basal nuclei. Okay. And we know Parkinson's disease and Huntington's disease is involved with this area, substantia nigra. Parkinson's disease and Huntington diseases, they both are neurodegenerative diseases. They have lots of similarities, but again, are very different disease. We'll see that in the later parts of the slides. So all that we have to understand here in this slide is that substantia nigra present in your midbrain is involved with neurodegenerative diseases, mainly of Parkinson's disease. Okay, so you can, in this view, we can clearly see the substantia nigra is, so it's this brown structure, and then the red nucleus is just very close to it. Okay. Just give me a second. Okay. So we weren't able to see periaqueductal gray matter, the other view. Let's see, you can see it here. It is basically this structure here. Okay. So the periaqueductal gray matter basically is involved with, what did I say? Pain suppression, and also with, yeah, fight or flight responses. So, okay. So we'll move on to pons. So pons basically is located between the midbrain and the medulla oblongata. Okay. Fourth ventricle separates pons from cerebellum. So there's no shortcut. You've got to remember this. What will actually help is looking at the actual slides and visualizing them. Okay. So pons actually helps in helps the origination of various cranial nerves, mainly 5, 6, 7. Okay. And some of the nucleus present in pons also plays a very important role in reticular formation and helping in the maintenance of normal rhythm of breathing. We'll talk about that later again. Okay. So the next one is medulla oblongata. Medulla oblongata is also known as medulla. It's a very, very important structure. So again, it's got lots of control centers there. It's very hard for anyone to survive without medulla oblongata. If medulla oblongata is damaged, then life cannot progress. Mainly because medulla oblongata is a structure that actually connects to the spinal cord. So if that's lost, the connection to the spinal cord is lost. So none of your spinal nerves are going to emerge out from the spinal cord. Okay. So this medulla oblongata actually contains fourth ventricle within it. Okay. And medulla also has a very important structure called choroid plexus. What is that? Anyone can remember? No? So which one? Choroid plexus? Choroid plexus is mostly your capillary blood supply. Okay, so it's a capillary rich blood supply, and this choroid plexus also has one other important function. It just not supplies the blood to the brain, but most importantly, the filtrate formed from this choroid plexus or from the blood actually forms the CSF, cerebrospinal fluid. And cerebrospinal fluid basically helps in control of various functions within the brain. So if something affects choroid plexus, for example, if there is no medulla oblongata, there is no cerebrospinal fluid actually, isn't it? So no medulla oblongata, then there is no choroid plexus, there is no CSF. Okay, there is no CSF, no life. Also, medulla oblongata actually connects the spinal cord, if you can see. So that's important for imaging of all the spinal nerves as well. Okay, so there are different structures in medulla oblongata that we need to concentrate. Pyramids, I'll talk about these all in the later slides. I've just put them together there. We won't worry about that yet. Okay, so this is again with sagittal section to visualize the hypothalamus. It is this, again the same color. So this is your medulla oblongata. Okay. Right. So here we can see the different nuclei distributed throughout this medulla oblongata or the brainstem as well. So if you look at that, first we'll talk about pyramids. So what are pyramids? They are the ventral longitudinal ridges, as you can see. These ridges are actually formed by the pyramidal tracts that we already spoke about. Okay, that connects the motor cortex region. And then we have olives, not again clear, but somewhat like this structure here. Okay, so the olives are nothing but swellings caused by this inferior olivary nucleus, and it actually helps in passing stretch information from muscles to your cerebrum and cerebellum, all those areas. Okay. Then we also have in your brainstem we have the other nerves, cranial nerves, 8, 9, 10, 11 coming out. Okay. Sorry, 8, 9, 10 and the 12th one, not the 11th one. Okay. So your vestibular nuclei and your cochlear nuclei, they are involved with balance. Okay. Balance and equilibrium as well. So again, medulla has many functions overlapping the hypothalamus, mainly because it's acting as a relay station as well. And there are different functional groups present in medulla, mainly the cardiovascular center, controls your cardiac center. Vasomotor center, what does it do? Can you guess? So it actually controls your blood vessel diameter. So that means it's going to be very useful for maintaining your blood pressure. That's right. Okay. Then we have the respiratory center, and there are various other centers as well present within the medulla oblongata. Your vomiting center, swallowing center, coughing, sneezing, all that is again controlled by medulla oblongata. Okay. We'll move on to the next structure, the cerebellum. So where is cerebellum? Sorry, cerebellum, where is it present? At the back, isn't it? So cerebellum, this is actually the smallest portion, so it's around only 10% of your total brain mass. But interestingly, it's got more than half the percent of neurons present in your overall brain. Okay, so it's again a very, very important structure. So this is involved with coordination, balance, and with language or learning control as well. Okay, so coordination, balance, and learning process. So it's very important, especially for learning. You got to have good health of cerebellum. Okay, there are different lobes again. So you can see the main function is, as I told you, coordination and balance. Okay. So these cerebral hemispheres, again, there are two hemispheres. These are connected by a structure called vermis, which is more or less like a worm-like structure. I can't see it here in this view. I'll show you later. It's coming at the back. So both of your cerebellar hemispheres, they stand separate and they're connected in the center by a structure called vermis. Okay. And what else do we need to know here? So each hemisphere has 3 lobes: anterior lobe, posterior lobe, and your flocculonodular lobe as well. 3 of them. Okay. So folia. This is the leaf-like structure that you see here. That's called as folia. And then you have the different lobes here. You see your anterior lobe. This is your posterior lobe. And this is the other lobe. Can't see here. The other lobe is not seen in this view. But in the next slide, I think we'll see that. So you can see here the flocculonodular lobe. Okay. Right. So, this structure here that connects both the cerebellum hemispheres, cerebellar hemispheres, is called as vermis, the center one here. Okay. Right. And this slide, again, the main thing that we need to concentrate here is highlighted in red, the cerebellar peduncles. So the cerebellar peduncles has three important nucleus within it. So superior nucleus, middle and inferior. Okay. And very interestingly, all the fibers present in your cerebellum are ipsilateral. What does ipsilateral mean? Contralateral is actually crossing and connecting to the other side, but ipsilateral is they run in the same fiber or within the same hemisphere. Okay. So what were the different fibers that we talked about in cerebellum, in cerebrum? There were three important fibers. We talked about three important fibers in cerebrum, and similarly we have three fibers here as well. So we talked about association fibers, commissural fibers, and projection fibers, isn't it? So with cerebellum, we have superior fibers, middle, and inferior fibers. So basically, your superior fibers, this one, connects cerebellum to midbrain. Okay. And second is your middle fibers, which actually connects pons to cerebellum. They basically help in connecting different regions. And the last one, inferior fiber, actually connects your medulla oblongata to cerebellum. Okay. So this slide, you just have to understand the different fibers. That's enough. All right. So cerebellum basically controls most of your fine motor activities. Okay. So it receives information from cerebral cortex and initiates your voluntary muscle movements. And the various other important functions are, and also it receives information from your proprioceptors. What are proprioceptors? So these are again sensory receptors that are involved with your position and your movements as well. Okay, so it receives information from proprioceptors, so basically helps in balance. Okay, sorry. Yes, sort of, yes, but there are other areas that also look after that. That's part of this cerebellum as well, cerebellum functions. Okay, so cerebellum, as I told you before, remember the three important functions we talked about. So basically, it helps in coordination, balance, and in your learning abilities as well, or language skills. Okay. In this slide, all that you have to understand is it is important because it gets information from cerebral cortex and coordinates fine movements, and also it receives information from your proprioceptors. Proprioceptors, they are dispersed throughout your body. Okay, and these are sensory receptors that actually communicate to the brain, communicate to the cerebellum about the balance and about the position of the body. Okay. Right, so you're moving into the very important section. We'll talk about the functional brain systems now. So this involves, there's lots of different networks of neurons that actually work together. Doesn't matter where they are dispersed in the brain, but these work together and produce a different set of functions that are looked after by them. So your limbic system and your reticular formation systems are two important functional systems that we need to know. Let's start with limbic system. So your limbic system again involves different nerves and networks, basically present near the cortex region. Okay, and these limbic systems are involved or concerned mainly with your mood and your instinct as well. So when I say mood, it basically controls your emotions. Okay. Okay. So what does limbic system do? It actually puts your emotional responses and associates it with different memories. For example, when you think about skunk, we always think about the bad smell that's coming, isn't it? So that's because of your limbic system. And also the limbic system, mostly its output is actually coming through the hypothalamus. And that's why we see hypothalamus controlling most of your function as or maintaining your homeostasis. Okay, so and you can see it also plays an important role in your memory. Right. So let's talk about reticular system formation here. Basically, this reticular system extends through central core of your brain system. Okay, there are three important columns that actually runs in your brainstem. First is the raphe nuclei. This one in purple. That's the raphe nuclei. So this is a nuclei that's actually present in your brainstem. Okay. Then we have the medial group of neuron nuclei. Okay, we won't worry about where it is, but what it does is it actually sends out lots of networks throughout your brain that actually helps or stimulates your balance, and also it basically finds out about how alert we are. So when your reticular formation system is active, you're mostly listening to the class and you're awake. Okay. But when your RAS system is down, that means we are entering into a sleep pattern. Okay. Okay. So again, reticular activating system controls most of your visceral motor activities such as vasomotor centers, the diameters of the blood vessels, cardiac center, and your respiratory center as well. Okay. So if someone has an injury with the reticular activating system, then they can actually never come back. So they enter into a permanent unconscious state called coma. Okay. So reticular activating system is very important to keep you alert. So again, these slides I'm not going to go through, but they're important. They're like summary slides which actually tells you all the functions of the different regions. I've put them there. All right. So higher mental functions involves all these 5 functions that you can see in the slide. Okay. We'll talk about them in detail here in the next one. So language. So language is again controlled by the left hemisphere. Okay. So with language, in the left hemisphere, there are 2 important structures that you need to understand. One is the Broca's area and the other one is the Wernicke's area. So the red one here is the Broca's area. Okay. So what it does is, the Broca's area basically helps in production of speech. So if someone has a problem with Broca's area, they cannot speak. Okay. The next is that blue mark there, which is called as Wernicke's area. This is important to understand what words, important to understand the spoken language. Okay. So the first one, Broca's area, is important in speech production. The other area is important in understanding the spoken language. Okay. So patients obviously with a lesion of Broca's area cannot talk. Patients with lesions in Wernicke's area cannot actually, they can speak, but and again they can hear what you speak, but it doesn't make sense to them because they can't coordinate that or put the information together, consolidate information. Okay. So here again, this is Broca's area, and this shaded area is Wernicke's area. Okay, so we have finished language, we move on to memory. So with memory, there are different kinds of memories involved. Okay, so first one is the declarative memory. So declarative memory is usually important in remembering the different faces, names, words, dates, country names, and all those information. So procedural memories, this is important to remember any procedural process that we have to do. For people to do chemistry, they need to have good procedural memories. Okay. And next is your motor memory. What do you think this one is involved with? Can you name any one skill that will control the motor memory skills? Motor skills? Coordination? Yep. Your driving skills can be related to this? Yes, all that come under motor memory skills, that's right. So your emotional memories is a different set of skills. Again, basically, this, if it's active, alert, and also it's a motivational skill. Okay, so emotional memory is also important. So you could see a child who is motivated to study well or receives constant motivation from parents usually perform better than child who is suppressed, who is found fault with and other stuff, isn't it? So the emotional memory is important to perform well as well. Again, there are different stages of declarative memory. The first one we have seen. So short-term memory and long-term memory. So short-term memory, so this short-term memory we can remember around 6 to 7 facts at a time. But for it to progress to long-term memory, there are certain important, for it to progress to long-term memory, there are certain important factors that needs to be done. Basically, so your emotional state should be alert, isn't it? So if you're sleepy, you can't then put them into long-term memory. You have to be alert. Then rehearse the information, basically repeat and practice the information a few times, remember them. And also, association skills is important because there's lots of information to be stored and there are few information already stored in your long-term memory. So it is important to associate with the stored information that's already present. Okay, so if it doesn't make sense, for example, so when we talked about different ion channels entering in and entering out, we were talking about examples with little kids moving in and out of the doors and stuff. So those type of memory is called as association memory, associating it with something else that you already are familiar with. Then automatic memory. So this again involved with your long-term memory process. So basically having the capacity to grab knowledge and memory consolidation. Above all, whatever information that has to transform into your long-term memory, the information you read or write has to be consolidated. Okay? If that's not done and if you keep on adding information, it's going to be lost. Okay, these are the other important factors that increase. So basically here you can see temporary storage information and then moves into short-term memory. And with all these factors that we have discussed now, it can then move into long-term memory. Okay. So the homeostatic imbalance here mainly is if your hippocampus is affected, what can happen? We can go into a state called amnesia. Okay. So what's amnesia? Alzheimer's disease is a good example for amnesia, but what's amnesia? Memory loss? Yes, that's right. In simple terms, it's memory loss. So there are two types of memory losses. One is anterograde memory loss. So this one, they still have very much intact long-term memories. Okay, but what happens is the recent past is lost. Okay, so for example, say a 30-year-old man who's got recently married, he could remember, if he goes into anterograde amnesia, he can remember his parents, his childhood friends and everything really well. But he would have forgotten just a part of the episode, like his girlfriend, marriage and all those. So he doesn't have any connection with that. So that part is called as, that type of loss is called as anterograde loss. So where you have your long-term memory still intact, but the recent past information is lost. Then you have retrograde amnesia. And this is loss of memories found in the distant past. So just opposite to that. Okay? Right. Moving on to a very important topic. brainwave patterns and your EEG. So what's EEG? I use the mouse all the time. What's EEG? The electroencephalogram. So basically tells you about your brain functions or brain waves. So we know this very clearly that all the signals are changed into electrical signals before the brain can actually read them. Okay? So what is the normal brain functions? They are continuously working, and it is very hard to measure without this EEG. So basically this EEG records electrical activity that's present in your brain activity, in your brain function. Okay? This is very important in diagnosing various brain defects, okay, and also to monitor different functions of your brain structures. So this is how they measure, this is how they do the electroencephalography. Basically connect electrodes all over to your brain region, and then they measure the wave velocity or your brain wave velocity. So your brain waves, there are different waves that's present when you do different actions. Okay, so this is basically measured in hertz. So the frequency of your brain waves is measured in hertz. Hertz is nothing but number of peaks that you see per second. Okay, I'll show you the waves later, but understand. The first one is the alpha wave, which has a frequency of 8 to 13, and this is usually present when you're calm and relaxed. Okay. Then your beta waves, they are in the frequency of 14 to 30 hertz. Did we give a break? Okay. They are in the frequency of 14 to 30, and these beta waves are present in people who are actually alert and active. Theta waves, they are in the frequency of 4 to 7 hertz, and they are usually very common in children. Okay. Then your delta waves are there. Delta waves are 4 hertz or less, and these are more prominently present when you enter into a deep sleep. So that's in deep sleep mode, deep cycle, or it's also present when someone is under the influence of anesthesia. Okay. So again, these are the different waves. So you can see that the frequency changes along. So alpha waves when you're awake and alert. Beta waves again awake and alert. But see, alpha waves is present when you're relaxed. Okay. So the frequency, what I want to see here is, the frequency is very less for delta waves. So you can only see there are few peaks. They just drag along and expand. Okay. Whereas your alpha waves, you can see it's very, there's not peaks there. So it's sort of calm, the alpha waves. Beta waves, this one's present when you're awake and alert, so you can see the frequency actually is higher than the alpha wave. So clinical homeostasis, the main thing that you would see is problems with brain functions is seen as what? Oh, let's flip to the other slide. So seizures, isn't it? So the victim may lose consciousness and have uncontrollable jerking as well. That's called as seizures. Again, what happens is, it's possible for people to enter into a state of hallucination. Sensory hallucination is common side effects that's seen after epileptic seizures. So what happens is, when they come away from that epileptic episode, they sort of get scared about the environment. Okay, so that's quite common. So sensory hallucination, for example, this picture here, you can see there's imaginary visualization that few people are harming her. So that sort of sensory hallucination can happen, and that's called as aura. Okay, and with little kids, the seizures usually do not produce any jerky movements. So if you see with febrile conversion stage, you commonly see jerky movements. But kids or infants, especially in infants less than 1 year, they don't have these type of seizures. So what they have is mild seizures that's actually happening in their brain. Okay, that is called as petit mal. So what happens is you don't see seizures there, but these kids just go into a state of freeze mode, like a rat when it curls up its toes. So that type of symptoms is what you actually see. So they have the seizures happening in the brain, and the hands and legs are all tucked up together. That's called as petit mal. This tonic-clonic conversions, this is very common in adults. There you see people have fits. Sometimes it's very violent, where they even break their arms and legs, and those type of vigorous reactions that's seen in tonic-clonic convulsions. So what is the main treatment for this? They give you anticonvulsive drugs, and also they stimulate the vagus nerve. The vagus nerve, it's involved with relaxation, so they stimulate these vagus nerves as well. Okay, so we're going to talk about consciousness. So consciousness is perception of sensations. So you're awake, alert, and you're able to respond to any sensation that's happening. Okay, this is important for memory process or memory lodgement, logical and judgment processes as well. Okay, this basically involves lots of different areas present in your cortex or cortical regions. And it is also just not the cortex, but it is various other centers or interconnected for one's being to be physically active or mentally active as well. Okay. So there's a problem with consciousness. So we can enter into different disease conditions or different imbalance conditions. So it is expected that except during sleep, consciousness signals should normally be present in your brain. Okay. So the first one is fainting. So what is fainting? Fainting is loss of consciousness, but this is a brief period only. Okay. This is mainly due to inadequate cerebral blood flow. So people with low blood pressure, and if they're standing for a long time, then it's possible for them to have this imbalance. So they might faint very often, people with low blood pressure, because they don't have adequate blood supply to their cerebral areas and they faint. Okay. Coma, this is unconsciousness for extended period of time. Okay. This is not again same as deep sleep, because in your deep sleep mode, the oxygen consumption is still high. Okay. But with coma, the oxygen consumption is actually lower. Okay. Brain death, we call this condition as an irreversible coma. Okay. There is no chance they're going to reverse back to normalcy. So that's brain death. Okay. So sleep, there are different stages of sleep again. So what's sleep first? So your cortical activity, so I told you consciousness involves various areas of your cortical activity control. So if your cortical activity is depressed, then we call that as sleep. Okay. So here in sleep conditions, your cortical activity is depressed, but your brainstem activity is still intact. Okay. And there are different stages of sleep. As you can see here, there are different EEG patterns. So people who have gone and done sleep study would know about these different ways. They would have talked to you about these. So when you're awake, so you're awake and alert, your cortical activity is awake. And you can see this type of waves. So when you're alert, what type of waves do we see usually? Beta waves. That's right. So the sleep pattern alternates between your REM, rapid eye movement, and non-rapid eye movement patterns. Okay. So there's alternate cycles of REM and NREM happening throughout your sleep. So first it starts with NREM stage 1. So this is the first stage where you step into your bed, you sort of feel relaxed, your skeletal muscles start to relax, and when you if they check your brain waves, then they will see lots of alpha waves. Okay? Then the second stage, the EEG is a little bit more irregular, and so you're entering into a little bit of more relaxation here, and then move on to so this is the first and the second stage happens within the first 30 minutes. Okay? But if you're sitting with your iPhone or sleeping with your iPhone, looking at the different websites, then it's not going to help. You're not going to get to that stage yet. Then you enter into your third stage, NREM stage 3, where your sleep actually deepens more. Okay? And your brain waves there is usually theta and delta. So theta waves we didn't discuss. It's not necessary here, but just understand, in your deep sleep mode, you enter into your brain waves are more theta and delta waves. Okay, and in this stage 3, most of your vital signs actually starts to decline. Then stage 4, this is mostly delta waves, as you can see, and most of these symptoms like bedwetting, night terrors, and sleepwalking also occurs during stage 4 for some of them. So we call stage 3 and stage 4 as slow wave or restorative stage. So we have to have different cycles like stage 1, 2, 3 and 4. But 3 and 4 is very important because it helps to restore your body for the next day functioning. Okay, so we call that as restorative stage. So if you're normal, so after you go into your sleep, after sleep starts, your stage 4 usually completes by the first 90 minutes. Okay, and then you enter into this REM stage. Okay, so rapid eye movement stage. So here you're completely relaxed and most of your dreaming occurs at this stage. Okay, and what happens with REM stage? Your oxygen, your heart rate, breathing, everything increases. Okay, so remember, during REM, everything increases. And during the stage 3 and stage 4, again, your heart rate, your intestinal motility, all that also starts to show some changes here. Okay. Okay. So normally, as I told you before, you enter, there's alternate cycles of rapid eye movement and non-rapid eye movement happening throughout your sleep cycle. Okay. So your reticular activating system has to be inhibited for sleep to happen. But again, your reticular activating system sort of mediates the actual sleeps as well. Okay, although it's inhibited, it is actually mediating sleep patterns. And hypothalamus is the main brain structure that actually regulates your sleep patterns. So hypothalamus actually secretes a chemical called as orexins, which helps in stimulating sleep. Okay, and do you remember the nucleus name that we talked about that's mentioning your sleep and wake cycle in hypothalamus? What is that? No, that's that in a different structure. Again, a nucleus that was suprachiasmatic nucleus. Yeah, still good, very good. So sleep regulation, it's again looked after by hypothalamus. Okay, so importance of sleep. Basically, I told you stage 3 and 4 is important because it actually restores your body back to normalcy. And as people age, getting restorative sleep starts to decline as well. Okay. So they say that after the age of 60, it's possible that they don't get any restorative sleep at all. Okay, so some of the sleep disorders. First one is narcolepsy. There's lots of movies that's featuring this condition, isn't it? So narcolepsy, this is a condition where people abruptly fall into sleep state. So they lose their consciousness, they enter into deep mode sleep at least for a few minutes, and then they get back to normalcy. So this is because of this chemical, orexins. This body, it's an autoimmune reaction where the body constantly destroys these orexins, these chemicals, and they sort of fall into sleep. Okay. Insomnia is a condition where there is inability to obtain quality sleep that's necessary. And again, research has found that these orexin hormones are destroyed in narcolepsy condition. So that can actually be used as a treatment for insomnia. So if they administer that, if they block these orexins for these people suffering with this insomnia condition, they actually can get quality sleep then. Okay, so we'll move on to talk about different protection layers of the brain present. So there are three important ones: dura mater, which is the outermost layer, then arachnoid mater, the middle layer, and third one is the pia mater. So dura mater again has two layers within it. So it has the periosteal layer and the meningeal layer as well. So the periosteal layer, this is present in your brain, okay, but it doesn't continue to the spinal cord. So your brain actually needs a little bit more protection than your spinal cord. Okay, so there's two layers of dura mater present in your brain, but as it descends down to the spinal cord, the periosteal layer is not there. So it only has meningeal layer. Okay, and then the periosteal layer, the dura mater also extends. If you can see here, the dura mater also extends into the cortex region. Okay, this sort of helps in splitting the brain regions into different boxes. So there is sort of prevents those rapid movements. Okay, if they're concealed within different boxes. So that's actually looked after by dura mater protection. And also you can see the blood vessels and other structures are all kept intact, and also it prevents unnecessary movements because of these different layer protections. And it is also important in sinus formations within your brain structures. See the importance of that later, but now, yeah. So the dura mater actually forms different layers, different separations. So we have, okay, before we go to this slide, we also talk about these structures. So arachnoid mater. So these arachnoid maters, this is the second layer, and there is a layer in between this arachnoid layer and pia mater which is called a subarachnoid space. And that's very important as well. There's lots of significance with that space. We'll talk about that later, okay? And pia mater is the brain protection that is very closely adhering to your actual brain structures. Okay? So the dura mater, there are three important structures. Three important septors. So first is your phalanx cerebri. Yeah. This one basically is a longitudinal fissure, and it separates your cerebral hemispheres. Then you have phalanx cerebelli, which is again covering, that is engulfing just the cerebellum. Okay, that's not seen here. Then we have the tentorium cerebelli, which is a horizontal fold and just hanging over the cerebellum again. So I told you cerebellum is a very important structure. So there are lots of protection in nature. Okay, so here this is a good slide. So you see phalanx cerebri, tentorium cerebri, and phalanx cerebri. These are the septa that's coming out from your dura mater. Okay. The main homeostatic imbalance we see here is meningitis, which is inflammation of the meninges. And if meningitis is not spotted and cured, the infection actually can spread into the actual central nervous system, which then we called as encephalitis. Encephalitis is more serious than meningitis condition. So meningitis, how do we identify meningitis? So this is through a lumbar puncture. Yeah, they usually do this for little kids. They take a sample of cerebrospinal fluid during the lumbar puncture, and then they test for any microbes or even just alteration in the constituents of the CSF. Yes. It can be anything. It can be viral or bacterial, but encephalitis happens soon after meningitis. Like once meningitis sets in, you have certain symptoms there. If that's not actually captured there, then your internal central nervous system starts to get affected. It can be microbes of any origin, can be a bacteria or a virus. So the lumbar puncture will actually tell you whether it's viral or bacteria. So they collect the CSF and then get to know. So cerebrospinal fluid, so it's more or less a watery solution similar in composition to blood plasma. But again, the proteins in the CSF is a little bit less than the blood plasma. And the ions are also altered in composition compared to your blood plasma. Okay. So choroid plexus, the main blood supply, that actually, choroid plexus helps in formation, or it filtrates out the cerebrospinal fluid, and then the cerebrospinal fluid is in constant circulation through these different ventricles, first ventricle, second, third and fourth ventricles. It circulates around. This is very important because CSF sort of bathes the whole structure in water. So that's actually helping in reducing the weight of the brain structures. So if the CSF wasn't there, then the brain structures would just collapse on each other and the neurons will start to try. Okay? So it keeps the weight under control. And also CSF is important because it sort of protects and also nourishes. It provides the nourishment necessary for your brain structures. Okay? So here the first one is, so here you can see the choroid plexus, number 1, there, marked 1 there, here, actually produces CSF. And then it slowly moves into the subarachnoid space, number 2, here. So the CSF takes a path and moves into the subarachnoid space. And then from the subarachnoid space, the CSF flows into the dural venous sinuses, all these regions. And here when it comes to the dural venous sinuses, there is a granulation present in your arachnoid region. Through that it also enters into the dura mater region. Okay. Okay. So this is your capillaries, your choroid plexus, which actually helps in absorbing the waste and unnecessary substances. That includes waste products and also unnecessary ions. Then it's absorbed in there. And then the CSF is actually formed as a filtrate from the blood supply. It contains glucose, a little bit of proteins, oxygen, vitamins that's necessary for the brain cells, and also has different ions like sodium chloride, magnesium, and many more ions. But these are the 3 ions of the many important ones present in your CSF: sodium chloride and magnesium. Okay. And also you can see these ependymal cells continuously beat to circulate the CSF throughout your brain structures. Okay. So next is the clinical imbalance that you can see in newborn children, called as hydrocephalus. So what happens is, due to some blockage within their brain structures, the CSF is blocked. So it doesn't circulate well. So there is accumulation of fluid within the brain structures. Because in infants, the brain structures are not yet fused. So there is gapping, so it expands and accommodates this extra fluid. Okay. But if the same condition happens in an adult, the brain structures are already fused, so there is no way the pressure constantly increases within the inside because of accumulation of fluid. And what can the pressure do? It can actually kill the neurons. Okay, so it can start to degenerate the neurons. So it's a serious condition in adults, whereas in little kids, it can be cured. Okay, without the neurons or the nerve cells being affected. Okay, so the main treatment would be to drain the CSF, isn't it? Because there's blockage, they create a shunt in the ventricular shunt and drain it to the abdominal cavity. Okay. Next important topic is blood-brain barrier. This is very important. This barrier sort of helps in maintaining a stable environment within the brain. Okay. Otherwise, any changes in your blood composition can affect the brain instantly. So we don't want that to happen. So nature has provided with a barrier where the normal microbes and ion changes does not affect the brain instantly. Okay. So substance actually pass through. To enter into the brain, substance have to be passing through these three layers. First, they have to pass through the endothelium of the capillary walls. Then they have to pass through the basal lamina. And then there's lots of astrocytes within your CNS. And these astrocytes are glial cells, supporting cells that actually help in maintaining homeostasis. So for anything to enter into your CNS, there should be three checks. First is the endothelium. Entering into the endothelium is hard. Then the basal lamina is again hard. And then even if it even enters the basal lamina, then we have the astrocytes, which actually fights these infection cells. Okay. But there are certain substances that can actually cause the blood-brain barrier. So, for example, fat-soluble substances can pass, that is, including alcohol, nicotine, and anesthetics, can pass your blood-brain barrier and enter into your CNS. Okay. So this is astrocytes, protecting the neurons. So brain injuries and disorders. So concussion. So this is just a temporary alteration in brain functions. Okay, and you get a little blow. Contusion is a little bit severe because there is permanent damage there. Okay. Next is your subdural or subarachnoid hemorrhage. So if this bleeding happens, what can happen? Bleeding within your subdural space or your subarachnoid hemorrhage can actually lead to death, isn't it? And then cerebral edema, again this is associated, can lead to death as well, and this is associated with head injury. Okay, all these. So there's just the different degrees there. Cerebrovascular accidents. So what can they happen? So ischemia. What is ischemia? So ischemia is tissue deprived of blood supply. So when tissue is deprived of blood supply, it is also deprived of nutrients necessary, isn't it? So that's ischemia. And glutamate is a neurotransmitter. And what it can do is, during ischemic state, the glutamate composition within the CNS sort of increases. This neurotransmitter causes excitotoxin. It's an excitotoxin, which means it can affect, or it sort of keeps you in an alert condition. So most of your food substances from fast food and other restaurants, they usually add this glutamate. They add it as a MSG, monosodium glutamate. So this basically increases the taste of the food. So you sort of get attached to it. What happens is then this produces excitotoxin to your brain, and it is lethal if it's consumed continuously. Okay. So lots of Japanese food in Maine, they actually add these MSGs. So this next condition is hemiplegia. So hemiplegia, this is paralysis on just one side of the body. Okay. So what happens when there is paralysis on one side? There may be some speech deficits happening as well, normal paralytic conditions. Then we enter into a different condition called transient ischemic attack, where this is reversible cerebral ischemic condition. Okay. Then TPA, tissue plasminogen activator, is administered as treatment for strokes. So cerebrovascular accidents are also known as strokes. So they administer this plasminogen activator as a treatment for strokes. So degenerative brain diseases. So this is how your normal brain looks, the left side. Okay. Once, for example, in Alzheimer's disease, certain areas of your brain starts to degenerate and slowly spreads to the rest of the areas as well. So an Alzheimer's brain looks somewhat like this on the right side. You can see there's lots of degeneration here. Okay. So there's memory loss, disorientation, and language loss as well. So at any stages they don't speak. And there is also moodiness and confusion. They also undergo hallucination. So it's a very pathetic condition. There are lots of symptoms are seen in them. So this is mainly because of, trying to bring this down. Okay. This is mainly because of plaques present of beta amyloid peptide. Okay. So this peptide starts to form plaque formation within the actual brain structures, destroying the neurons there. Okay. So eventually, most of the neurons will be killed and the brain would then shrink down. Okay. So Parkinson's disease. Parkinson's disease, which area is involved with this? Basal nuclei, isn't it? Parkinson's disease and Huntington disease both involve your basal nuclei. So there is degeneration. So Parkinson's disease, this involves degeneration of your dopamine receptors. So basically, there are some similarities as I told you before. Both are neurodegenerative diseases. They degenerate over time and both of them involve basal nuclei. But what is unique with the diseases is, for example, Parkinson's disease, it's deprived of dopamine. So what is dopamine's role? So dopamine is important for motor control, then learning, and also for being motivated. So when the motor control is lost, what we will see in Parkinson's disease is motor activities are first affected primarily. Okay. So the actual cause is not known, and treatment includes giving dopamine precursors, and also because of depressive conditions, they also need brain stimulations. So motivation is lost, so they need brain stimulation and other supportive therapies as well. Next is the Huntington disease. So Huntington's disease is because of loss of a neurotransmitter called GABA. Huntington disease is a hereditary condition, unlike Parkinson's disease. So with Parkinson's, we don't know what the actual cause is, but we know for sure it's not a hereditary condition. But Huntington's is a serious condition which is hereditary, and what happens is, if the first generation had the strike of this disease around 40 years or 50 years, then the next generation to follow usually are 10 years younger. So it's a very serious disease. Again affects your basal nuclei. This is mainly because of loss of GABA neurotransmitter. So GABA is a very important neurotransmitter that is important in controlling your motor activities. Okay. So if GABA is lost, and they cannot control their motor activity. So when you look at people suffering with this disease, they are into a sort of dancing movement most of the time because there is no control. So they can actually start the action, like they would try and grab something, but that fine motor skills is lost, the control is lost, so there's sort of, this is also known as chorea, this disease. Okay, it's sort of the dancing pose. So the initial symptoms includes wild, jerky, flappy movements, and slowly it can also deteriorate their mental abilities. Okay, so within usually fatal within 15 years of onset. So how do we diagnose various CNS dysfunction? First is the simple knee-jerk reflex. Okay, they do this, and if they see any abnormalities, then they refer to CT scans, MRI, and PET scans. And cerebral angiography is also done. So angiography is usually administrating some sort of dye along with X-rays and finding out where the actual pinpoint hemorrhage or clot is present. And ultrasound is also done to evaluate if they have proper blood flow feeding the brain arteries. So all these will put together the actual story what they're undergoing.